In this video, I will go over various definitions, most of which regard plane geometry or configuration types. It will be in a semi-alphabetical order. There will be some visual aids, but it can be watched with just audio for the definitions. An airfoil is the cross-sectional shape of a wing, which are usually shaped like this in the NACA series. The root is the section of the wing closest to the fuselage. You can see here along this line. The tip is the farthest out section of the wing. The chord is the measure of the wing's length from front to back, this distance here. Aft means backwards on a plane or towards the tail. The aileron is the control mechanism at the tip of the wing that allows the rear part of the wing to rotate up and down like a flap, and is primarily used for turning. You can see them pictured pointed up in this design. The angle of attack, abbreviated AOA, is the angle of the plane, though more specifically the wings, relative to the motion of the air. This is equal to the velocity of the plane if there is no wind. However, if there is wind, that must be added to the plane's velocity to determine AOA. Anhedral is when the plane's wings are angled downwards, and dihedral is when the plane's wings are angled upwards. You can see a dihedral angle here, like this, a very slight, around 3 degrees. It's around 3-degree angle, and if it were in the opposite direction, it would be anhedral. The aspect ratio is the ratio of the length of the wings to their average chord. A biplane is a plane with 2 sets of wings, with one wing above the other. Camber is when the airfoil shape curves upwards. As you can see, it happens a lot more in the 3412, which I just clicked on, as opposed to the 0010s. The camber is indicated by the first number in the NACA series. A canard is a type of plane configuration where the wings are placed in the back and the horizontal stabilizer is in the front. You can see it one pictured here. The center of pressure is the location along the longitudinal direction, which is X in XFLR5, where the average location of lift is. A delta wing is a triangular wing shape where the tip chord is 0. You can see one pictured here. The elevator can be synonymous with the horizontal stabilizer. However, in the Aero Club, this will usually refer specifically to the flaps on the back of the airfoil. You can see them up here, whereas this whole section is the horizontal stabilizer. A flying wing is a plane design with no horizontal stabilizer added. It is purely wings which are melded and blended with the fuselage. The fuselage is the structure that connects the wing to stabilizer surfaces, or the structure that houses the payload. A high wing is a plane configuration in which most of the mass is located below the wings. You can see on this one where the wings have been elevated so that they are now far above all the masses here. A low wing is the opposite, where the mass is located above the wings. A high wing is commonly used because it is more stable to have mass under the source of lift, which is similar to the principle of stability on helicopters, with the body located below the rotors. The horizontal stabilizer is the horizontal surface that balances the plane and is usually synonymous with tail. However, tail can refer to this entire section that also includes the vertical stabilizer. The vertical stabilizer is used to stabilize the plane's yawing, and the rudder is located on the vertical stabilizer to allow the plane to turn, which you can see pictured here and here, as they are both turned as opposed to blending with the rest of the airfoil shape. Induced drag is drag from producing the plane's lift. This is what the CD graphs here in XFLR will refer to. It is induced drag. Parasitic drag is the drag from the plane's cross-sectional area forcing against the air. This coefficient is added to induced drag to get the total drag. Vortex drag comes from turbulent flow and the vortices that tend to form around non-smooth objects and the wings tips. If you go to an analysis and check, go into the angles and then check stream, you can kind of see the spiraling vortices out on the edges near the wingtips. How they curl around, that is vortex drag. Laminar flow is fluid flow that is smooth, like you see straight lines coming off of the wing here. Turbulent flow that is fluid flow that is chaotic and spiral shaped and tends to produce more drag. This is what we want to avoid, is turbulence. The lateral axis is the line connecting the two wing tips, so from here to here, which would be Y in XLR5. The longitudinal axis is the line connecting the nose of the plane to the tail, which is X in XFLR5. The mean aerodynamic chord is a line representing the quote-unquote center of the wings, which is usually about 25% of the chord back from the wing's leading edge here, so about 25% back. So it approximates something like this on this plane. The offset is the number in XFLR5 for adding sweep to the wings. You can see here, if you were to increase it, they move further back. The pitching moment being force times distance. The pitching moment describes how the plane wants to turn around the pitch axis. If you go again into angles and then check moment, you can see the direction it wants to go in your analysis at that specific angle. It varies a lot when you change the angle. Roll, yaw, and pitch but all describe different ways of the plane turning, and their axes are depicted here. If you are just listening, you may want to look at this picture to get the full gist. Yaw describes turning to the left and right. Pitch describes turning up and down, which is towards the ground or sky if the wings are flat with respect to the ground. The rudder is the control mechanism at the back of the tail used for turning. The semi-span is half of the total wingspan, or the length of one wing, so like from here to here, that distance. Span refers to the total wingspan of the plane. Stall is a characteristic of flying where the lift suddenly rapidly drops off, either to a decrease in speed or more commonly an increase in the absolute value of the angle of attack. You can kind of see it on your coefficient of lift graphs in viscous, where the line starts to go downwards at more extreme angles. Sweep is when the wings are angled forwards or backwards. You can see sweep pictured here, whereas there is none on this design. Swept, unswept. The wings are almost always swept backwards because that increases the plane's stability. Tapering is when you make the tip chord smaller than the root chord. As you can see here, it's thicker at the tips and wider at the roots on this design. Thrust is the force propelling the plane forwards. Twist is when the tips are given a different angle than the rest of the wing. So they're at an offset angle compared to the root. This is done so that the tips, which tend to be less efficient, will have different stall characteristics than the rest of the wing. We will almost never twist the wings on DBF planes, but it can be done in XFLR5. As you can see here, the tips and the root are angled very differently when you add these boxes, or give them values. A V-tail is a type of tail configuration where the tail is split into two pieces and angled around the fuselage so that they can provide vertical and horizontal stability. It can be done in XFLR5 if you go to fin, check double fin at a dihedral angle, usually around like 60 degrees, and that will give you a V-tail. Although 50 degrees also works pretty well. If you're looking for a real-world example of this, I would suggest looking up the F-22 Raptor. And that is all I have today for various aerodynamics terms we will use in the DBF Aerodynamics Club. Thank you for listening.